Good afternoon, everyone. I welcome you all after a refreshing lunch break. We are about to commence our next talk with next speaker. It is my pleasure to introduce our esteemed speaker for this evening, Professor Susmita Ghosh. Professor Susmita Ghosh received with the BSc with honors in physics and the BTech in computer science and engineering from the University of Calcutta, MTech in computer science and engineering from IIT Bombay, and PhD in engineering from Jadavpur University, Kolkata. Professor Ghosh has completed about 20 national international projects and has visited various universities for collaborative research international projects. She has published about 100 research papers, internationally reputed journals, and referred conferences, and has edited 3 books. As per Google Scholar, her H index is 29 and item index is 55. She is an associate editor of 4 international journals. She is a former chair of IEEE Geoscience and Remote Sensing Society Kolkata chapter. Sushmita Ghosh was a lecturer and then associate professor with the Department of Computer Science and Engineering in Jadavpur University since 1997. She is a full professor at the same department since 2010. Her research interest includes computational intelligence, pattern recognition, machine learning, data science and big data analysis, image and video analysis, and cognitive computing. Let's welcome Professor Susmita Ghosh for her enlightening session. Hello, am I audible? Hello? Very good afternoon. A very good afternoon to one and all. I'm very happy to be here and to share my ideas on very introductory lecture on artificial intelligence, machine learning, deep learning. So, first of all, I would like to thank the 2 conveners, the conveners, Dr. Saxena, Sanjay Saxena, and Dr. Deepak Rao, for organizing this wonderful workshop, for taking the pain in organizing this workshop. Okay. So I thought of providing you a very introductory talk on this particular topic, consisting of the overview of the whole methodologies. Before going into the details, I would like to know that how many of you have backgrounds on these AI/ML neural networks. Please raise your hand. So not much. So that is why this introductory talk is meant for, so that people can dive into DLAI. Okay. So I will talk on, as I pointed out, I will talk on initially. I will touch upon artificial intelligence, then machine learning, very brief, and then we will move on to neural networks, artificial neural networks, and then to basically deep neural networks. time permits, I will try to give you a glimpse on what are the topics that we are working at this present moment on, particularly concentrating on deep neural networks. So we noticed that the artificial intelligence is basically started long back, and then gradually we have with us machine learning, then deep learning. Nowadays, everybody is working with either ML or DL, and they are obtaining a very good success, very good accuracy in many of the problems. Now, what is the motivation behind this deep learning? Look at this picture. Can you see the change? Or is there any change at all that is taking place? So you see that there are several changes, right? As and when we are looking at the rightmost top right corner, some change will be visible. And when we are concentrating on bottom left corner, some more changes will be visible. So by looking at the whole image, it may not be possible for me to tell you that how many changes are there. But whenever we are concentrating on one particular region of an image, possibly we are obtaining better and better information. And this is what deep learning does. It tries to automatically find out the intricate details which is present within the image. Okay. So this is in short, and let us see how does it work. So this is my roadmap. As I mentioned earlier, I will initially give you a brief on intelligence and AI, ML, DL. Then touch upon on artificial neural networks, single layer, multi-layer. I mean, how deep learning has come up in today's era. So then gradually we will move on to deep neural networks, particularly because the shortage of time, particularly I will concentrate on one particular deep neural network, convolutional neural network. Okay, and then some application area. So as you can understand that the bigger set is nothing but artificial intelligence. Now, what is the aim of artificial intelligence? To make machine intelligent, in short. How, where, when, how, I'm not going into the details at this point. Just to make machine intelligent is nothing but AI. Now, we can have different types of methodologies to make machine intelligent. For example, using expert system, search-based methodologies, learning-based methodologies, etc. So there are different methodologies exist to make a machine intelligent. Among them, learning-based methodologies is one such. Okay, so the next one, subset, learning-based methods. Now, within the learning-based methods, maybe machine learning is one such approaches, where using some methodologies, we are trying to make the machine learn. That is also one of the criteria for labeling it as an intelligent. But to label a machine as an intelligent, there are different approaches. One such approach is using machine learning techniques. Now, under machine learning, we have several processes: classification, clustering, feature selection, feature reduction, and others. Outlier detection, abnormality detection, different steps, different processes, different methods. Okay, so these machine learning techniques may take place with the help of classifiers, with the help of different, for example, KNN classifier, support vector machine classifier, random forest classifier. Similarly, we may have different clustering approaches, for example, K-means algorithm, DB-scan algorithm, different hierarchical clustering approaches. Okay. So these are some of the examples of machine learning methods that I have just uttered, its names, terminologies. And within these, there is a subset called
deep learning. Okay. Now, in deep learning, you may come across those who are working under deep learning, they come across several such methodologies, several deep neural networks. Convolutional network, neural network is one such. Besides this, we can also have recurrent type of neural network, RNN. LSTM is one of the specialization of RNN. And then we may have some other. Nowadays, people are working on large language model. Wherever you go, people will talk about LLM. Okay, so this is nothing but main research topic under natural language processing and combining both NLP domain as well as machine learning domain. We also have generative modeling where we can generate some data out of a given set of data also. And that is very much necessary for some applications because one of the main constraint of using machine learning is that you have to have sufficient amount of data. So there are certain examples where you may have some data, but that amount is not necessary to run any machine learning methodologies. So you need to generate some data. Okay? So there are certain techniques under deep neural network. Generative adversarial network is one such, through which we can also generate data. So this is in short, basically the scope of DL and AI workshop. Okay. Now if we go into the intelligence part, start from the very beginning, from very scratch. What is intelligence? Intelligence cannot be defined. Only its power, we can feel that okay, person A is intelligent and person B is not intelligent. So if you have intelligence, I can feel that. Okay, so one of the main component behind the success of intelligence is the cognitive abilities. If I see your face for 2 days or 3 days, possibly in the 4th day, I will be able to recognize you. I am holding one particular thing. By looking just, it is in occluded fashion. By looking this also, you can understand that, okay, I am holding one leisure pointer. But if I give this sort of picture to the machine, and if I ask that, can you tell me that what this object is, the machine will not be able to provide you the answer, correct answer. Okay. So the cognitive ability plays a role behind the success of an intelligent object, intelligent human being. So we notice that human mind is principally governed by reasoning with knowledge contained in it. So we show our intelligence through different kinds of reasoning mechanisms. Along with that, we do also have some kind of knowledge. Okay, so note that I need to have the cognitive ability, I need to have the reasoning mechanism with me, that reasoning power, as well as I should also have some knowledge. If these three are there, and if we exercise my reasoning abilities with the help of the knowledge and the cognitive abilities, probably I can exhibit some sort of intelligence. Okay? So, intelligence can be captured by defining knowledge and by the mechanism of reasoning analytically. And one of the striking examples that came forward long back in 1997, when the then chess champion Garry Kasparov was defeated by an IBM-made chess program. And the name of the chess program is Deep Blue. So you can understand that Garry Kasparov was, you just imagine that Garry Kasparov was the chess champion, but he lost the game with one particular software. So what was there inside it? Probably it was a threefold strategy: high-end computation, lot of such technique, and innovative multiprocessor systems. Nowadays we are having, very good processors. And then if we have a very smart mechanism for such technique, smart search technique, then probably we are done. We can find out a very good quality solution even if the search space is quite huge. So AI is a subject which is concerned with designing intelligent entities so as to behave like human. So intelligence is something which cannot be defined, it can be expressed. And artificial intelligence is nothing but a subject which is concerned with designing intelligent entity. How can we design intelligent entities? This entity could be a simple calculator. It could be some mechanical device. It could be a watch. Nowadays, you all are having smart watches. It could be camera, intelligent autofocus. Okay. It could be computer. It could be supercomputer. It could be GPU. Okay. So the thing is that we are trying to model a machine so intelligent so that it can behave like human being. Now, why I am comparing with the human intelligence of human being? Because becoming a human, I cannot think beyond the level of intelligence, beyond the level of human intelligence, because I am a human. Okay. So that is why while we are talking about, we are always talking about, okay, you do it up to the level of human intelligence. That's all. So with this, we see a lot of success, a remarkable success in various fields. For example, there are several breakthroughs in machine learning, in deep learning, natural language processing, computer vision, robotics, etc. Okay. Nowadays we have artificial robot. Robot which is a citizen of Saudi Arabia, Sophia. Okay. So now from intelligence to AI, I'm now moving on to learning. Because it is a vast topic, so that is why I have to spend only one slide for each one of the topics. Okay. So what is learning then? It says that learning is a process by which a system improves its performance from experience. So over a passage of time, I should improve my performance. Okay, that performance can be measured with the help of some performance measuring indices. But whatever be the index, performance measuring criteria, points, marks, or something else, I should improve my performance. So let me give you some examples. Suppose our driver every day drives his own car, and every other day, he is colliding either with a cow or with someone, or he is bumping, etc., etc. So if I tell you that is the driver learning how to drive, what will be your answer? Note that the driver knows all the rules: how to press the brake, how to accelerate, how to steer the wheel. But driver is not learning. If he is not improving his performance over a passage of time through experience, he is not learning. Similarly, you may listen my lecture, you may have the copy of my lecture, but you are not learning unless and until you are improving with this lecture material. This is very true, although it sounds harsh. Okay. So my message is that once you go back, try to go through some of the books, some of the things, do exercise. As I point out that exercise, reasoning, exercise, knowledge. Knowledge will be with you, all the PPTs. No useful thing, nothing. Okay. You have to exercise your knowledge over a passage of time. And then You have to have some cognitive ability. Probably we all have the cognitive ability. So you have to exercise, you have to define your knowledge over a passage of time. Then and then only this DLAI workshop will be effective for you. So I say that a program learns from experience E with respect to task T and performance measure P if its performance at task T as measured by the performance measuring criteria P improves with experience E. So if it doesn't improve, if suppose in the first semester I got 50%, in the second semester I got 61%, in the third semester it is 62%, fourth semester 63%, I'm learning. If it is not like that, if it is not steadily increasing, you are not learning. So this is what learning is. The next slide. What is then machine learning? Okay. So it is a field of study which gives the machine the ability to learn without being explicitly programmed. So automatically the machine is trying to learn something. And this is what machine learning is. Okay. So machine learning will be used in cases where, as I pointed out, we should have plenty of data. If I show you 2A, the character alphabet A, and then 3B, if I show a child twice A twice and thrice B, and if I ask the child, the difference.
The vertical line.
For both the cases, one vertical line, one half circle. But in B, the half circle is the right part, while in D, the half circle is the left part. So unless and until I show the B and D a many number of times, the child will not be able to point it out. Similar is the case with P and Q. Okay. So the machine we should provide the machine with plenty of data, and there is an intuition that a certain rule exists, but we do not know what the rule is. Through machine learning, we are trying to automatically find out the rule from the given set of data. Okay? Now it will not work. So, in case of where is the difference between traditional programming and machine learning? In case of traditional programming, we provide data. We also know the rule, the functional form, and we ask the machine to find out the output. Okay, so let us think in this way. In 11-12 mathematics, you used to work with you used to have x1, x2, x3 parameters of a function f. Okay, the functional form is also given to you. x1, x2, x3, the parameter values are also given to you. Now the task was to find out y. where y equal to f of x1, x2, x3 dot dot dot. Am I correct?
Yes.
So this was very easy. We know, since we know the functional form and we know the xi values, I will be able to find out what is the value of y. In case of machine learning, it is the other way. We know x, x1, x2, x3, and we also know the output y, but we do not know the functional form f. Okay? We know input, that okay, look, this is apple, this is tomato. And in machine learning, we say that each and every functional form, we say it as hypothesis. Basically, k nearest neighbor classifier is one such functional form f, is giving you one such functional form f. SVM is giving you another functional form f1. Random forest f2. Other classifier decision tree f3. So each and every classifier, basically supervised learning model, they try to find out the functional form f so that x gets mapped into y. Now, as you can understand that there are several functional forms f1, f2, f3, fy, as many as there are number of classifiers, different algorithms. That many, those many. And maybe I can also invent one, I can also propose one more algorithm as well. So that will be another f dash. So now the question is, which f is better? Because there are several f1s. The answer is the f which is as close as possible to the actual f, the f dash which is as close as possible to the actual f, that is better. But that is measured in terms of various performance measuring criteria. Accuracy is one such measuring criteria. There are other measuring approaches, measuring methods. Okay. So now we will move on to deep learning, and then we will keep on continuing that. So what deep learning is? The basic building block of deep learning is nothing but artificial neural network. This is basic building block, which is emulation of biological. What is artificial neural network? Emulation of biological nervous system. Through emulating biological nervous system or human nervous system, the researchers have developed a simulation or emulation of biological nervous systems, and it is termed as artificial neural networks. Okay. And these artificial neural networks attempt to mimic the activity of human brain using many layers of neurons, layer by layer fashion. Okay, each and every layer has certain tasks. Each and every layer does certain tasks. And deep learning is nothing but a set of learning methodologies which attempt to model the data. That modeling, F is a model, F dash is a model of the data, which attempts to model the data with complex architectures by integrating various nonlinear transformations. Because in real life, we notice that whatever the task that will be given to me, it cannot be solved using any linear transformation function. I need some complex nonlinear transformation function. So that is why deep learning plays a vital role behind the success of solving any task. Okay. So this particular model learns to recognize patterns in digital representations. The images will be acquired digitally, digital representation of sounds or images or other kinds of data. And deep learning has wide applicability in multimodal data analysis. And one of the biggest advantages as compared to machine learning methodologies of deep learning is that deep neural network can automatically extract features from the given set of data. Whereas the traditional machine learning methods, they were unable to do that. Okay. So this was one of the biggest advantages behind the success of deep neural network. In case of machine learning methods, we have to provide the features. A set of features will be provided to the machine for a set of patterns. The machine will learn that data. This consists of a data. The data means a set of patterns. Each pattern is defined with a set of features, followed by some class levels for supervised learning, and for unsupervised learning, no class level will be given. Okay. So, in case of machine learning, we provide the features and the machine tries to learn everything. Whereas in case of deep learning, we do not provide the features. The features will be automatically extracted from the given set of data. So this is very good for me. I don't need to concentrate on what could be the possible set of features, because sometimes it is so happening that I will provide you only the images. I don't say that what will be the features of those images that you can consider for further processing. Okay. So this is all in short that I already have shown you. Artificial intelligence is the bigger umbrella. Then machine learning, which creates algorithm that can learn from data and make decision based on patterns observed, but which needs human intervention because manual feature feeding. And then, whereas in case of deep learning, without human intervention, only I will provide the data, and the rest will be done by the deep neural network. So now I will just, because everything will be connected with neurons, and neurons. So I will give you in short the details of artificial neural network. So this artificial neural network, the basic definition is something like it is a massively parallel interconnected. It is a massively parallel interconnected net of simple processing elements. Each and every node is doing a very simple thing. Okay, but then their collective computational abilities, they are interacted. They have the connections among themselves, and since they have the connections, they have interconnections. So these interconnections and their processing power, through these, basically, it makes the neural network model a huge success. So massively parallel interconnected net of simple processing elements, which are intended to interact with the objects of the real world in the same way that we, the human beings, do normally. So these neural network models are extreme simplification of human nervous system, where each and every element is termed as neurons or nodes or processors, which does, as I mentioned, which does a very simple thing. Say for logic gates, maybe just AND function. One neuron is doing AND function, another neuron is doing OR function, another neuron is doing NOT. And you know, those who are from electronics or IT or computer science background, we all know that if we can model NAND or NOT, those are universal gates, we can model any and every complex functions. So we are done. Okay. So this is how a neural network works. So information flows in, it is processed, and the result flows out to its neighboring neurons. So this is one neuron. This neuron is accumulating input from its neighbors. This accumulated input will be, these inputs will be accumulated over here, summed it up. By using a threshold activation, some activation function, it will pass through the longer arm called action. And then by passing through the synaptic strength, synaptic connection, it will provide the information to its neighbors. There could be more than one neighbors, many neighbors in reality. Okay, so this is how information flows in, and then we get some information in its neighboring neuron. And they are built from simple approximation of biological neuron, which is nothing but nonlinear integration of many weighted inputs. These inputs are weighted ones. So this is the thing. Perceptron is nothing but a very simple neuron. This neuron is single neuron connected by weights to a set of inputs. Okay, so suppose here there are two inputs, x value and y value. X passed via W1 weight value and Y is passed through W2 weights. So these two weights will be, these two signals will be accumulated over here, summed it up. So we will get over here W1X plus W2Y. It will be passed via some activation function. In this case, it is threshold activation. If some value is greater than theta, it will be 1, else 0. Then output will be obtained. Now then what is the output? Basically output is, if W1X plus W2Y is greater than theta, then the output is 1. Right? Else output is 0. Now the equation says that W1X plus W2Y greater than theta, output is 1. So if I map it something like W1X plus W2Y plus say C is equal to 0 is what? Equation of a line? AX plus BY plus C equal to 0. Equation of a line. So this two input perceptron is providing me a line. Okay. So if I change W1 and W2, I will get different orientation of the same line. Now suppose I have two classes of patterns, and I am asking you to separate them out through a boundary, through a decision region, through a decision boundary. So in case of 2D, two dimension, probably it could be a line. In case of 3D, it will be a plane. In case of 4D, it will be hyperplane, and so on. So the task is to find out a suitable line so that both the classes are well separated. Now how can we find it out? If I change W1 and W2, I will be able to get many different orientations of this line, and some of the lines will serve my purpose. And you can understand that if I change these W1 and W2 in the perceptron, the neural model, I can get this decision boundary. Okay? So a neuron can act as a classifier. Just a single neuron, note down its power. It can act as a classifier. It is classifying the set of patterns. If AX plus BY plus C greater than 0, then class 1. If AX plus BY plus C less than 0, then class 2. Something like that. It is the class 9-10 mathematics linear inequation that we used to solve. Lower region, lower part, one region, upper part, another region. Exactly the same thing. So a neuron is providing me a decision boundary. Now, this, because some line may not be correct one, I may not generate a good decision boundary. Some of the patterns may be misclassified. So I have to change the orientation of the line. So how can I change? So I need to change the weight values. Yes. So how do I change the weight values? So it should follow certain rules. This is the learning rule. So present a set of input patterns, adjust the weights until the desired output occurs for each of them. I will show one pattern. Try to find out whether my line is giving me the proper classification, correct classification or not. If yes, then I will fit the next pattern. If no, then what will I do? I have to change the weight values. Okay? So these are the rules. This weight value change will be in proportion to the earlier weight as well as how much error I have occurred. If you put some if you incur certain penalty, the degree of violation will be in proportion to the degree of penalty. The amount of fine that you have to impose is in terms of the degree of violation. So likewise is the case. Okay. So WIT plus 1 will be WIT plus del I, where del I is in proportion to delta. Delta is nothing but the target value minus actual, that means the error, amount of error that I am incurring, as well as xi is for the particular pattern, ith pattern. And what is eta? Eta is the proportionality constant. And we, the neural network who does some work in neural network, we call it as, can any one of you point it out? What do we say as eta? Learning rate. Very good. Okay. So, but there is a catch. I mentioned that a neuron can provide you a decision boundary. Not always. In which situation it will not provide you decision boundary? If the patterns are not linearly separable, then single layer perceptron will not provide you decision boundary. It will keep on oscillate. And we need multi-layer and as well as non-linear activation function. Okay. So that is, note that we had single neuron, we had single layer perceptron. Now why do I move to multi-layer perceptron? Because single layer unit will not be able to provide you the correct decision boundary if the patterns are not linearly separable. What is happening then? The whole story, it is something like initially some random guess for W1 and W2, and this is the decision boundary. Is it a correct decision boundary? No. So we can understand that we have to move towards shape, left. So this is what machine is also doing. Note that amount of error earlier, now it has reduced. But still we have to move. Probably now I am done. So this is that learning rule, whatever I have shown. But if the patterns are linearly separable, then this neuron can work well, otherwise not. Say for example, exclusive OR function. In case of exclusive OR, the two input XOR functional form is something like 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. Okay? So 0, 0, 0, 1 white dot, 0, 1, 1, x0, y1, red dot, x1, y0, red dot, x1, y1, white dot. Now the task is we have to separate these 4 patterns, each row one pattern. There are 2 features x1 and x2, and that is why we could plot it into the coordinate. Then these 4 patterns cannot be well separated with a single boundary, because if I place the boundary over here, then this one is correctly classified, these 2 is also correctly classified, but this one not. Now if I change this boundary to here, this one will be correctly classified, these 2 also, but this one not. So you can understand that a single neuron will not be able to provide you a good decision boundary if the patterns are not linearly separable. So I need multi-layer perceptron. I need more layers. So cascading layers. Generate convex decision region. I need to generate, with the help of neural networks, I would like to generate this decision region. How can I do so? There are 2 lines. So I will have 2 neurons. Okay, so these two input units providing me one line, suppose S1, and these two input units with this neuron is providing me another line S2, and then S1 and S2 will be combined together. So you see now I have inserted one more layer to have convex decision region. This one is convex. If I would like to have concave decision boundary, the decision boundary is something like this. We would like to have non-convex region A but not B. So then that means what I am trying to get? This one along with this, then this one and this. A but not B. So this is concave region. So for that, I need one more layer. So you can understand that if my data gets complicated enough, maybe more and more number of layers will be needed to have a good decision boundary. And hence, the multi-layer perceptron came into the picture. Okay. So there are certain roles for having hidden layers. The layer between input unit, input layer, as well as output layer. There are some intermediate layers, we call it as hidden layers. And these hidden layers play a major role for the success of artificial neural network, for the success of deep learning. So, these intermediate layers could build up multiple levels of abstraction, and through these features can potentially develop. The features will be developed through these multiple hidden layers. For example, in visual pattern recognition, neurons in the first layer might learn to recognize the edges, only edge, very simple thing. Then second layer, more complex shape, say triangle, which are built up from edges. The third layer would then recognize still more complex shapes and so on. Okay. So these multiple level of abstractions seem likely to give deep networks a compelling advantage in learning complex pattern recognition tasks. So that is why we have with us feed-forward neural network. Input unit, hidden units, not necessarily only one, then output units. In input unit, we will provide the input x1, x2, xn. Then in hidden units, basically it tries to learn the abstract of the given data. Nonlinear decision boundary would be obtained through the hidden units, and then output unit will provide with the output value. So we have with us multi-layer perceptron given by Rumelhard, Macmillan backpropagation algorithm. So we have inputs with us, set of hidden layers, feed forward in nature, no skip connections, no self loop, okay, all in forward movement. And then the goal of this type of network is to create a model that correctly maps the input into the output. It is a kind of supervised network, neural network, which does supervised learning, as I mentioned, that if we have X and if we have Y, it will try to find out the mapping function. So the as you can understand that here also there will be set of weight values for each and every connection. These are weighted connection. But these weight values need to be changed to learn the given set of data. How to change the weight values? For that, backpropagation learning algorithm exists in the literature. Okay. Initially, the network will be fed with the set of patterns, and the error will be calculated at the output layer. Based on the amount of error, the weight value will be changed. There are two phases. The first phase is forward pass, calculate the output value. Second phase is reverse pass or backward pass, where error is propagating backwards, and hence the name backpropagation algorithm. error backpropagation algorithm. Error is propagating backwards, initially from output layer to last hidden layer, then last hidden layer to the next one, and so on, then the first hidden layer to input layer. So when the error will be propagating backwards, accordingly the weight values will be adjusted. Now once the weight value is adjusted, then again we will show the network a set of given patterns, given set of patterns. And again the error value will be calculated. We are aiming that the next iteration, the error will be reduced as compared to the earlier one. This process keep on continues, we call it as epoch. Keep on continues until the error value is within some tolerable limit. Now once the error is within some tolerable limit, we show the test data. For the test data, I am expecting that the model will be able to provide me the output. Okay. So as I point out, as I mentioned, that machine learning, we have input, human in the loop, then we do training, then it can classify tree or not tree. But in case of deep learning, we have automatically with us the feature extraction capability through deep neural network plus training and then the similar output. But for that, one caution is we should have sufficient number of training data, and you can understand that there are lots and lots of parameters are need to, the model should learn large amount of parameters. And it is not always possible for the model to learn properly those many number of parameters. There are many parameters. So basically sometimes what is happening, it is nothing but a case of overfitting where the training accuracy is quite good, but test accuracy is very poor. Okay. So this is one caution behind the use of deep neural network. So as I point out, as I mentioned, in traditional method, we use handcrafted features and simple trainable classifier, we have the output. But this approach is tedious and costly and highly dependent on one application. And this set of features cannot be transferred to other applications. This set of features is very specific to one particular application area. If I move it to other application area, probably I will have different setup. I should have different set of features. But in case of deep learning, those who are working with deep learning, nowadays people are working with pre-trained model. So already some portion is already trained, and then now you keep on training with your new data, so that the time is reduced. In case of deep learning or representation learning, it seeks to learn rich hierarchical representation automatically through multiple stages of feature learning process. So low-level features, then mid-level features, high-level features, then we will have trainable classifier. So these are automatically learned, increasing level of abstraction. So this was quite good. So we can understand that, okay, if I put more and more number of layers in between input and output, I can model a complex relationship for a given set of data. So that is why people were keep on adding more and more number of layers as hidden layers. But there was one bottleneck. If we keep on adding more number of layers in between, ultimately we noticed that it is not learning. It is not giving me better accuracy. Say for example, suppose eta equal to learning rate equal to 0.1 and momentum equal to 5.0, and then we are having 784 neurons in input layer because the size of the image is 28 plus 28. So we have this many pixels, so these many inputs in the input layer. Then if we have only one hidden layer, 30 neuron in output, we see accuracy is this one. If we add 30 more, accuracy this much. And if we keep on adding 30, accuracy is not increasing. Okay. Why? The problem is vanishing gradient problem. the neural network is suffering with vanishing gradient problem. What the problem is? The problem is this one. If I have only two layers, only one hidden layer, the delta 1, that speed of learning in layer, delta 1 is 0.07 and the next initial output layer, output to first hidden 0.31 and first hidden to input 0.07. Now if I add one more layer, 0.283, 0.060, 0.010, rate of change of weight. Then if I keep on adding more and more number of layers, you see the rate of change is moving towards 0. So if there is no change in the weight value, the network will not learn. Network will keep standstill. I'm thinking that the network is not, the accuracy is not increasing. So let me increase the number of layers. In turn, what is happening inside? The network is not learning at all. So this was the problem with many layer neural networks. Okay. So we noticed that, in short, we have this simple neural network model. Gradually, what we will be moving on to that. This is what we can do. Basically, in this case, you see that there are 4 inputs, 4 neurons, then one there, super here. So how many parameters? 4 cross 4, 16. Then these 4 and this one. Total 21 parameters in case of multi-layer perceptron. Now, the life is very simple because I have only 4 inputs. Suppose I am showing this one to the network. How many parameters? This is 400 cos 400 size, 3 due to RGB. So we have 48 lakhs input. This one 48 lakh and then 1. So how many parameters? 48,000 cross 48,000 plus 48,000 plus 1. So approximately to 30 billion parameters. Will the network learn? Will you be able to learn those many number of parameters? No. On the contrary, if we have this 48,000 will always be there. But instead of having 48,000 over here, if we have only 1,000, note that it is from billion, it has reduced to million. Now we can learn. And deep neural network does this. It has the facility of shared weight architecture. Okay, how? Let us see. So what we are doing? We have one filter with us. Size of the filter is also be specified by here. Suppose here 3 cross 3. This filter, and we also have this image. I will move this filter over this image throughout, and I will have one map. I will convert this filter to this image, and hence the name convolution. Convolutional neural network. Okay. So what I am doing? That was the grade level image, an RGB image. This is its values in reality. So I am feeding this and basically moving this filter throughout the image, doing convolution operation, convolving, and then obtaining this one. Okay. So if I have different filter, I will get different image. If I have, I will get hundreds of images. We say 100 such feature map. Okay? These feature maps will be feeding into the fully connected layer as the flattened layer of the deep learning model. And then only one dense layer may sometimes suffice, sometimes more than one also. Some reduced number of hidden layers, and then we will have the output. So, in turn, we are reducing what? The number of parameters. We do not have that vanishing gradient problem also, because not many hidden layers are present. So this was inspired by Rubin and Wezel in 1962. So this is convolution. I think I can show you in short. So this is input image. You just keep on following, and that one is filtered. So we will have convolved image. W1 is A plus W2B plus W3E plus W4A. That is what H1. So the H1 will be put over here. Then it will move. I will have H2. H2 will be put in the next. So this process continues. So how many parameters do we have? W1, W2, W3, W4. Only 4. If I have one filter, the size of the filter is the number of parameters. If I have n filters, n into that many parameters. Okay. So number of parameters for one feature map is 4. If we have 100 feature map, we will have 400. Yes. So this is the case which is happening. This is filter 1 providing me this. Now we have filter 2, we will have other kind of data. Another feature map. Low level to more complex. Now in deep neural model, you will see that one component is convolutional layer, another component is pooling layer. This pooling layer is what is it doing? Just subsampling the feature sets. Basically to reduce the complexity, to reduce the spatial information. So that is why pooling is done. So there are mainly two kinds of pooling, max pooling and average pooling. In case of max pooling, we report the maximum. Over here, the maximum is 4. So I will have 4 over here. In this region, we have the maximum 5. Here 3, here 4. So if I use max pooling, I will get this matrix. If I do average pooling, I will get other. So likewise, this is the whole scenario. Filter, max pooling, and so on. And ultimately, whatever I am obtaining over here, this we will keep on adding. We call it flattened layer. Then we will have one fully connected layer. This one fully connected layer, and then finally, maybe the classification is showing the image. You need to classify with which type of tool is this. So similar is the case. Initially, it is special kind of multi-layer neural network, hierarchical learning, top to down, extract features automatically. So deep learning is excessive feature learning. This is the case. Normally we do convolutional, and we also use ReLU. Instead of using sigmoid function as we used to do in case of backpropagation learning in our MLP, here we use, normally we use ReLU. We can rectify linear unit. It is brings one sort of non-linearity. It transforms the given representation to other type of representation. And we also have other kind of activation function. We could also use sigmoid, tan hyperbolic, leaky ReLU, and other kind of activation function as well, depending on my problem. So this is all. I will just go through it. And because due to shortage of time, I am not giving you the details. You can see this is what is happening. We have two filters over here. These are the network parameters to be learned. Each filter detects a small pattern. You see, if my filter is like this, I am trying to find out whether there is an edge or diagonal edge or not. If my filter is like this, I am trying to find out whether in the given image is there any vertical edge or not. So I can also articulate my filter based on my task. If not, keep it random. the machine will automatically find it out. So if I use filter 1, provide dot product, you just look at it. So this is how we are calculating. Then this is the maximum one, 3. And here also we have obtained 1, 3. Note that 3 will be the maximum one because 1 into 1 plus 1 into 1 plus 1 into 1 is maximum value will be 3. And minimum value will be minus 3. So 3, but 1, 3 is over here and 1, 3 plus 3 is over here. So we can understand that, okay, there is one age here. Because this window and this window convert together giving me 3. So this edge is placed over here. Similarly, one more 3 is here. So this one. So likewise, different kinds of information you can obtain. You can also articulate. Repeat this for each filter. Another filter, filter 2. We will get vertical feature map. Similarly, maybe there are 2 filters with red and green outline. You see different feature maps. Different filter, different feature map. Value is what? As I pointed out, its output is given by output equal to max of 0 and input. It is an element-wise operation and replaces all negative pixel values in the feature map by 0. It also has certain disadvantages. That is why nowadays some people are also working with leaky element, where even if it is 0, the maximum is not 0, but some values are there. So this output feature map will be considered as rectified feature map. As I pointed out, we may have other activation functions as well. Okay. The next on pooling layer, I already mentioned how do I do pooling. So this pooling layer is 4 cross 4 image. So maximum is obtained. Okay. Then in case of average pooling, we will do the average in the window. This is nothing but subsampling. Why subsampling? Because we see that subsampling pixels may not change the object. I should not write will, I should say may not change the object. Then we have fully connected layer, the last one. Okay? Whatever we are obtaining as the feature map, we will just keep on augmenting all these. We have the fully connected one, flattened layer, fully connected feed-forward network, and that's all. So the advantage is that, as I pointed out, shared waves. Note that instead of having, here we have 6 plus 6, 36. So I would have, had it been the MLP case, I would have 36 plus 36. But here we have only 3 and 9. Instead of 36, we have only connected 9 inputs, not fully connected. Because the window is 3 cross 3. So 9. And this 9 is also shared. I will show you fewer parameters, only 9. Okay? And this rate corresponds to rate. Now you see in the next slide, I am moving this window. I will have next version. Okay? But these weight values are shared. The same filter is moving throughout the image. So weight values are shared. So still fewer parameters. So shared weights. So the whole CNN architecture is something like we stack a few convolute layer and then followed by spool. We repeat the pattern until the image has been merged spatially into a small size. The last fully connected layer will hold the output such as the spools. So convolute max pooling in image but smaller. Then the whole CNN convolute max pooling together. Then we can repeat this. We will have new image after convolute and max pooling. Then again we will feed this. The number of channels is the number of filters. Again convolute max pooling. This process continues. we will have transformed representation of the feature map. Then finally, we will feed it to the fully connected flattened, feed it to the fully connected layer. Ultimately, the classification score. Okay. So, but as I pointed out, one of the caution is that we have to tune a set of hyperparameters. Learning besides the other parameters, weight, filters, weights, etc. So, learning rate, number of epochs for training, size of the filter, window size, and stripe. Stripe means how much I will shift each and every time. Then the number of blocks in the CNN architecture and how do I design the blocks. So I just pointed out that there are different optimizers exist. Most popular ones are gradient descent optimization, Adam as optimizer. This one is adaptive using adaptive learning rate optimization, RMS crop, group mean square propagation. We also can use different kind of loss values, mean squared loss, how much error I'm incurring, the machine is incurring. So it could be mean square error loss, binary cross entropy loss, categorical cross entropy loss, sparse categorical cross entropy loss also. And this is the normal course for any deep neural network model. Simple one. Okay. So I will just go through with a couple of minutes. I will go through that. As I pointed out, that CNN is not the only one deep neural network model. We have many other kinds of deep neural network models in the literature. The very first one with a huge network architecture is AlexNet. Initial advancement of deep neural network is AlexNet. Developer was Geoffrey Hinton and others. Limitation is computationally expensive due to its large number of parameters, 60 million parameters. So here also the number of parameters is becoming quite heavy. And sometimes the network model may suffer from overfitting issue. This was the network mirror model, and it provides 18.2% error in image-based database. Then came into the picture in 2016, Visual Geometry Group, University of Oxford. They have proposed this network. Limitation is high computational cost due to deep architecture. 16 layers. Deep architecture is 16 layers, but high performance. This 16 worked fine, very well. Then afterwards, what is happening? We thought that, okay, we could have some skip connections also in between. Okay, so this feature will directly go towards this instead of skipping these two layers. And we have different kinds of ResNet version developed by Microsoft Research. This ResNet 18 basically consists of 18 layers. Each have convolutional layer, batch normalization, ReLU activation, and skip connection. This skip connection is designed to mitigate that overfitting issue. Machine gradient problem and enable training of very deep neural network more efficient. We also have ResNet 50 and ResNet 101. You can imagine the number of layers and the number of parameters that need to be learned. So this is the case, but we do have direct skip connections over here. Now people are thinking that okay, we are not being able to add more and more layer, and the network is not being able to learn also. Then what to do? Then some researchers added sideways. Instead of deepen the network, they broaden the network. This inception model is one such network model, where it is trying to deepen and broaden the network. Okay. Then we do have another kind of neural network which is termed as autoencoder, which compresses the input data into a latent space representation, and from this representation again it is reconstructed back with the aim that reconstructed image will be more or less alike to the input image. This has good ability also to detect anomaly, as well as this network can also act as generative model to generate new data. There are a lot of applications classification, detection, segmentation, image colorization, background removal, image completion. Some of the part is missing. Deep fake. Then, if you go to this side, you will see different faces, human faces. All are imaginary face generated by deep model, deep neural network. Image annotation, lip reading, text generation, smart reply. Nowadays, you also get smart reply in your mobile as a response. And deep learning and NLP together has done a lot in different arenas. Question answering, dialogue system, machine translation, Spanish learning. In video analytics also, not only images, not only in text part, you also have deep learning also has give its footprint into video processing. To solve any time series problem, we do have recurrent neural network model. Different kinds of recurrent neural network model exist. RNN, LSTM, GRU. This drone can automatically follow the forest trails to track down the lost hikers through deep neural network. In reality, a neural network designed by our group. We have last year we have model one deep neural network where we have introduced attention mechanism. On the existing deep neural network model, we have introduced one module called attention module, because as we have shown at the very first slide that where are the changes. So our attention basically moved from one particular region to another region. So if we can have some sort of attention module inside the deep neural network, probably my network model will provide better results. And we have obtained really very good results as compared to other existing approaches. 10 12 existing approaches, we have compared our model. So these were the attention mechanism. Here we have introduced one model, attention model. Okay. And we do also, afterwards we have one of my students, Oviru, he has done some work on other kind of attention, not only one temporal attention, but then incorporating spatial attention and self-attention. And this paper is also well accepted in one very good conference, which has just finished in Greece. It is a very good conference. It's one of the best conference under geoscience and emergency community. Tigers. Okay. So here also we try to introduce some kind of spatial attention mechanism as well as self-attention mechanism into the deep neural network model. And we compared it with 20 different types of neural network models, existing models. And our model provide better results as compared to all state-of-the-art approaches. All. You won't get anything better than this. We also have some work on activity recognition, and the result is also very good as compared to the existing ResNet 1850, even 101. But with reduced number of parameters. And we also have some work where self-guiding without self-supervision. Self-supervision without supervised model. Can we work? So from this, we are obtaining this one. This is the low light image. This is the output image. Without any supervision. And so much success. You also probably have recently came across the term Neuralink, Elon Musk's project, where a chip was inserted really within a brain of one particular person. So this is brain-computer interface, developing high bandwidth interface between the brain and computer. It has wide application in medical, aiming to treat neurological disorder like paralysis and Parkinson's. So you can understand the wide exploration in different areas. Neural implants using minimally invasive electrodes implanted in the brain to record and stimulate neural activity. So that later on we can combat with Parkinson's disease or other kind of neural diseases as well. So like this, how many miles we can go forward. We have Blue Brain project also that will be launched by world's first virtual brain within 30 years, artificial brain, which can think, which can respond, which can take decision and keep anything in memory. So we will be able to scan ourselves onto the machine. We will still alive beyond our death also. After the death of the body, the virtual brain lab doesn't happen. So maybe we can see this scenario also in near future. But there is a lot more that we also have to do work upon. We, the human being, are having this compassion, intuition, desire, value judgment, common sense. Whereas on the contrary, in the machine, we are feeding with deep learning, we have skill mathematics, fact checking, GPU. But then we have to have some kind of good interface and ethical way to design all these into the machine so that the machine can also work fine. These are the some references. Thank you all.
Hello. Thank you, Professor Ghosh, for this insightful presentation. For our online participants, if you have any questions, please type them in the Zoom chat. We'll address them shortly. And now I would like to open the floor for our offline participants. If you have any questions, please feel free to ask.
How can we find the suitability of the pre-trained model? Have to check the rent. Is there any way or?
No, there is no such guideline. Pre-trained model. There is no such guideline. Normally, people are using that kind of neural network, and then probably you have to fit into your existing data set. There are some problems. We also know. My student is also working with pre-trained models. Sometimes that some neural pre-trained model is not working fine with the data.
Do you think sometimes it may be misleading to use pre-trained model, which is trained in some other kind of database? And
So, my intuition says that if the domain is completely changed, probably it may not provide you good result. Otherwise, sometimes we see that it is providing good results. If we do not use pre-trained model, only one constant is that time. Time for running, time for learning the given data set should be quite huge. If we use pre-trained model, probably time for learning the given data set will be low. But there is a trade-off.
Madam, when we increase the number of layers, at that time the accuracy about the tested data is hampered. So will it be so? When we add the number of layers,
Yes, the accuracy diminishes.
is when we increase the number of layers, at that time the accuracy of the tested data will be affected. So how do we overcome that problem?
So that is the thing that I mentioned, that in case of MLP, multi-layer perceptron, if we were keep on adding more and more number of layers, we were suffering with vanishing gradient problem. That is what I had shown. Yes. Vanishing gradient problem I showed.
yes.
Is there any way to overcome that?
one slide I had shown delta 1, delta factor. The last one. So basically what is happening is that if we keep on adding more and more layers, the layer which are closer to the outputs, for those the weight value is changing. But the layers which are closer to the input, those weight values are not changing. So the layers which are closer to the input, if those weight values are not changing, overall the whole weight will not change. And hence what is happening that if we keep on adding more layers, even if we are expecting that it will increase my accuracy, it will not increase. So that is an issue. This issue is called vanishing gradient problem. And the one that you are mentioning is that you may have good is having many large number of parameters. If you could reduce the parameter 1 and if you could provide more data, probably you can escape from that overfitting issue. Okay. So this was the case that I had shown.
And sometimes, madam, it may happen that if I execute the same model number of times, I am getting different output.
Obviously, because your weight values, initialization of the weights are different. You are starting with different base.
It means my model is not giving 100% guarantee. Sometimes it may display 93%.
So that is why true. That is why we do not report in our paper. We never report the result of a single run. We report a result for maybe average of 50 runs to make to show that my result is robust. We show the average of 50 runs as well as we show the standard deviation for all those 50 runs. If the standard deviation is, suppose the average is quite comfortable, better, but standard deviation is very high, what does this signify? Each and every run is providing me results which are not close and compact, which are well separated. Maybe in one run I'm getting 92, in another run I'm getting 75, in the third run I'm getting 97, something like this. If this is the case, then only the average of standard deviation of all these runs will be quite, a large value. So our aim will be to reduce the standard deviation and to report the average of all these runs. This is what we do and our students do. Okay, not a single run. You are very correct that in one run, if you just run only one time, you will get 92% accuracy. In the second instant, test, p-test, t-test, etc. to show that my model is correct. Suppose some X paper has obtained 92.38% accuracy, and I have obtained, maybe average, I have obtained 92.50 accuracy. I cannot claim that my method is good, even if it is higher than 92.38. 92.5 is higher than 92.38, but I cannot claim that my method is good because that deviation 92.38 and 92.5 is quite less. So we have to have some sort of statistical test. Some statistical test exist. So we also show to show our method robust, we also use that statistical testing.
Research point of view, we should keep focus on the accuracy, but for real-time implementation, we should go for taking the average of.
No, from research point of view also, we will just try to think on if some paper shows some paper reports 92.38. I will not ask my student to go for publication with 92.50. Okay. Because the editors or the reviewers may not accept that. They will ask for statistical. From machine learning community, I am the associate editor of more journals. I know that people will ask for statistical testing. Many of the cases. For a good journal, your paper will not be, it will be published for conferences, but not for publishing in good journal. You please do that.
We have a question from Meenakshi Srivastava. How to fix an overfitting problem?
So that part I have Meenakshi, very good question, and we cannot fix it likewise. As I pointed out, it was same question was asked by one of the participants in offline platform. I hope you have obtained the answer. There is no, in one line, there is no steady state answer I can give you. We have to reduce the number of parameters of the network, as well as we have to increase the data, do a lot of execution of your program, probably will get better results.
Another question from Lakshmi. Which statistical test can be used?
That I have pointed out, that t-test, p-test, these are some of the tests, chi-square test, and other tests of Wilco means test also. Some other tests are there.
Okay, thank you everyone for your attention.
Madam, last question.
Please.
Standard percentage of accuracy. How do we say that my model is good? What percentage my model should be?
No, there is no such guideline, because you can understand that some patterns given set. The thing is that pattern classification or pattern clustering. So some patterns are good, well separated. So for that, those who work with our training, they do initially work with IRIS dataset. That IRIS dataset always provides 99.999 accuracy. But for Telugu Howell dataset, the second one that we normally provide to our student, they will get only 75% accuracy, and they will get frustrated. What has happened, madam? In that dataset, it was 99. So it depends on the complexity of the dataset. For some dataset, that is why you see that for some images, for medical image cases, and also there are something like 85% accuracy till date for some set of images, and for other set of images it is exceeding 99% accuracy also. And we are now working with one kind of environmental pollution images, the climate weather classification images. For that, initially there were 4 classes, and ultimately it reached up to 99% accuracy. So that is why researchers introduced newer data set, because it is already saturated. Thank you all.
Thank you everyone for your attention. We completely enjoyed this insightful session. And now I would like to invite Professor Sanjay Saxena to felicitate Ma'am Susmita Ghosh with memento.
Accuracy is only one criteria. People use to what we constant. Decision is what score AUC, ROC card, confusion matrix. That is just because of hyperparameter tuning. Your hyper, you have to tune your hyper. There is no guidance. We can try different optimizer. I have shown some of the optimizers, different loss functions. Because accuracy is increasing, loss is also decreasing. You see that loss value is approaching 0. But then at the end, that is accuracy is not.
For complex data set, we will get less percent.
Complex. That is the case. No, if I show you, if somebody shows me how it says, it is easier for me because I have seen it for a number of times. If somebody shows me Telugu, for me it is complex.
Can you share your
Yeah, and where are you from? I'm from Dryden.
and there are some more token of others.
Oh.
We just
Thank you so much.